Hi, I am Ravikant Sharma. I am a solutions architect at AWS based out of London. Welcome to the third video in the policy development series for Amazon Verified Permissions. If you haven't watched the previous two videos, please go and watch it. You can find the link in the description below. In this video, we'll have a quick recap of what we have learned so far in the previous two videos. We'll understand about policies and Amazon verified permissions, and we'll discuss how policies are used in authorization. We'll also learn about the test bench in Amazon verified permissions, and we'll then see policy creation in action in a demo for our veterinary portal application. And at the end, we'll talk about the next step. In the previous video, we learned about the Amazon Verified Permissions service and its features. We also had an introduction to the Cedar language and learned about the concepts of Cedar, namely principle, action, resource, and condition. To understand how these concepts applies to application, we have gone through the veterinary portal application. We defined the policy schema and learned why it is important to use schema in Amazon Verified Permissions. Now, what is a policy? A policy in Amazon Verified Permissions is a collection of permissions. These permissions are expressed using the Cedar policy language. Using Cedar policies, you can control what each user of your application is permitted to do and what resources they may access. Cedar policies consist of three parts: an effect, a scope, and an optional set of conditions. Based on the effect, there are two types of Cedar policies: an allow policy defined by the permit keyword or a deny policy defined by the forbid keyword. Authorization decisions are made against a body of data defined in a policy. For example, deciding whether an actor can view a resource would require knowing the identity of the actor, the resource, and the action they are attempting to perform. Beyond those basics, if rules refer to specific properties of the entities, then that detailed information is needed as well. Now let's discuss these components, the purpose of each, and how to use them to create access control rules. To represent this data, Cedar provides four variables that are built into the language. These variables are principle, action, resource, and context. Principle contains the information about entity that is authenticated and is performing the action. Action contains information about what the principle is trying to do. Resource contains information about the entity being used. Context represents information that is unique to a particular access request. At least one of these variables can be seen in every line of the policy. While the contents of these variables will differ between applications, the variables themselves exist in all Cedar policies. They represent the bedrock, so as to speak, upon which rules are expressed. Now let's look at some policies for our veterinary clinic portal application. As you might know, the Amazon Verified Permission policy engine denies any action that is not explicitly allowed with a permit policy. So I would start with building guardrails for our application. To do that, I'll create a policy that denies all actions across clinic if the requester, which is either a pet owner or a vet, does not belong to the clinic in which they are trying to access the resource. Can you guess what type of policy we should use? Probably you have guessed it right. We'll use a forbid policy and we'll add a condition on clinic ID attribute. If the clinic ID of the principal does not match with the clinic ID of the resource, then we should deny the access. Now let's start giving permissions as per our application. So first, let's allow pet owners to register their pets. Now since we are talking about allowing, we will use a permit policy. In actions, we will define register pet as an action, and since we are only allowing pet owners to register, therefore we will add the principal type condition to match with the pet owner type. Also, we only want the resource owner to register their pet, so we will add another condition on resource owner should be equal to principal. If you don't add the second condition, then any pet owner will have the permission to add any pet whether or not it belongs to them. Now, let's take a look at a policy for vets. What if there are users that require multiple permissions? For example, vets need to have read and update permissions on medical records. For this, we will define a permit policy with actions as read medical records and update medical records, along with a condition on the principal type attribute. So far, we have allowed pet owners to register the pet and vet to read and update the medical records. Are we missing something? Yeah, pet owners would also need to have read access to their pet's medical records. So let's define a permit policy that gives read medical records permission to pet owners by using the principal tag attribute. Now you have created some policies, so you would like to test them. To test the permissions, you would need to build the application code first. Or, is it possible to test policies without using them in application? The answer is yes. The Amazon Verified Permissions test bench allows you to test and troubleshoot verified permissions policies by running authorization requests against them. The test bench uses the parameter that you specify to determine whether the seeder policies in your application store would authorize a request. You can also toggle between visual mode and JSON mode while testing authorization request. This is useful in the sense that it enables you to test policies even before the developer has built their code, thereby decoupling policy building process from the code building process. Let's see how to create policies and test them in a demo. So I am into the Amazon Management Console. I'll start by searching for the Amazon Verified Permissions service, and I'll click on this. So we are into the service screen now, and I can see a policy store ID here. I'll create on the policy store ID. This is the same policy store that we created in the previous video where we have defined the schema. So let's quickly verify that. So if I choose schema here, I can see we have the schema defined. We have two modes, visual mode and JSON mode. And the namespace of the schema is veterinary portal. We have defined two principals, pet owner and vet, and we have defined three actions for these principals, which are read medical records, register pet, and update medical records on two resources, which are medical records and pet. We also have the test bench here. Test bench help us to test and troubleshoot the verified permission policies. It helps to evaluate all policies in the policy store to determine whether a particular request will be authorized or not. We have principal. We can select from the drop down whatever principles we have defined in the schema. We can select the resources here, and we can select the actions. And we can choose to run the authorization request once we are happy with the configuration we have defined in the test bench. Now let's start by choosing policies here. We will start creating policies for our veterinary portal application.
I'll start by choosing create policy, create static policy. Now, since we are trying to create a policy that will allow pet owners to register their pet, so we'll be using the effect as permit. Now for policy scope and resource scope, I'll use all principles and all resources for now. And in action scope, I'll go with a specific action that is register pet. Now let's format the policy. Here, since we are trying to create a policy that allows pet owner to register a pet and not all the principal, so we'll add a condition on principal type. It should be equal to pet owner. Our policy looks good. We do not have any errors or warnings, so we are good to go. Let me give a description for our policy, which is to allow pet owners to register a pet. I'll go ahead and choose create policy.
Awesome. So we have created our first policy and this policy store. Next, I want to create a policy for vet owners and I want to allow them access to read and update medical records. So let's start with creating a static policy. I'll choose permit policy and we'll go ahead and select specific set of actions which are read medical records and update medical records. I'll choose next, and in the condition I will define that should be principal.type should be equals to vet. This policy will allow vets to have access to read medical records and update medical records actions. Now we do not have any errors or warnings, which means this is good to go. Let's define the policy description. Let's choose create policy. Great, so our policy for vets is also created. Now I want to create guardrails for my application and I do not want to allow pet owners to register their pet in any other clinic or vets to access medical records of pets in some other clinic, which means only the principals belonging to a particular clinic should be able to access resources of that particular clinic. So what we will do is to create another policy, and this time I'll choose the forbid policy. I'll keep principal, resource and action as it is and will choose next. Here I'll define a condition on principal dot clinic ID should not be equal to resource dot clinic ID, because if this happens then we will not allow users to have access. We have couple of warnings here. Oh, I have made a typo on the clinic ID attribute. Let me fix that. Perfect. This is important because we could only catch these kind of errors if we have schema defined. Otherwise, this would allow us to proceed forward and then we will have policy validation issues later on. So it is important to define the proper schema early on. I'll provide the description. Deny all requests across clinic. And we'll choose create policy. Great, so we have created our deny policy as well. Now pet owners also require permission to view the pet's medical record. So we'll create another policy for pet owners and this time we will give them permission to read the medical records. So I'll choose read medical records and we'll choose next. Here I'll define a condition principal dot type. This should be equal to pet owner, and we will define another condition on resource dot owner should be equal to principal. Allow pet owners to read medical records of their pets. We'll choose create policy Great. So our policy has been created successfully. Now we have created 4 policies and we would want to test these policies. So we will switch to test bench. Now in the test bench, I'll start with selecting the principal. So first let me test for the pet owner. Assume we have a pet owner named Victor. We will define a clinic ID as Houston. I'll copy it, I'll need it later. Our type would be pet owner. Is email verified would be set to true. This will be used in the application. As of now, we haven't defined any policy that uses is email verified. So this has no effect on the authorization request as of now. For resource, I will use the pet named Luna. The clinic ID should be Houston and the pet owner should be Victor. In action, I should have register pet. So we have defined a request and let's test the authorization request by choosing run authorization request. So the decision is allow because it satisfies a policy that allows pet owner to register their pet. Here, if let's say I change the resource clinic ID to London, ideally it should not allow me to register it because the pet owner belongs to the clinic ID Houston and the resource is now in London clinic ID. So let's see if this denies the request. And yes, our policy framework is working as expected. This request has been denied. Now let's test a condition for vet. So I'll select vet here and I'll name the vet as Rashmi. Clinic ID would be Houston. Type should be vet. So let's say this vet wants to access the medical records of a pet whose owner is Victor and the clinic ID is Houston. Now the action is read medical records. Here we have 2 options because we have allowed vet to either read the medical records or update the medical records. Now we have to choose an attribute which is MF authenticated. We have defined this in the schema and this is to ensure that the sensitive data is protected with a multi-factor authentication. Since the medical records are sensitive data, so we have protected it with MFA. However, we haven't defined policy based on this, so it does not have any effect as of now on the authorization request. So I will now check further and it is asking us to add additional entity because we have added Victor as the pet owner here. So I'll quickly add it and we'll edit a couple of fields. The type should be pet owner for Victor and his email verified should be true. Let's run and it should allow. Perfect. So we can see that our policies store policies are working as expected and they are following the schema which we have defined. That's it for the demo. Thank you. As part of this demo, we created few policies for our veterinary portal application where the pet owners can register their pets and view the medical records, and vets can update and view the medical records of the pet. We also tested the policies using the test bench and learned how to troubleshoot the policies. In this video, we learned about the policies in Amazon verified permissions and how we can use the policies in authorization. We also learned how to test the policies using the test bench and how to troubleshoot the policies. At the end, we implemented the policies for veterinary portal application in the demo. I hope you have learned something new about the Amazon verified permissions today, and you can now create your own policies and test them using the test bench. Happy building on AWS. To learn more about Amazon verified permissions and schema, please scan the QR codes on the screen. Thanks.